Hey folks, good morning. How's it going? This is Mr. Moray coming to you with a do now for course 2 honors. So in this, we're going to do a little bit more practice with bearings problems. I recommend that if this was really difficult for you, and I completely understand, believe me, completely, go ahead and go and take a look back at the notes from the previous lesson and the videos. And if you're still stuck, maybe even this will be a good practice. But remember, like I said, bearings are not easy. We're going to continue to work at them. And absolutely no judgment from me, okay? I'm here to help. So here's the situation. Arbys OVO mobile takes off from Port Life's Good at 10 a.m. with a bearing of 150 degrees and a speed of 70 miles an hour. At 1 p.m., 3 hours later, the OVO mobile changes course to 40 degrees west of south, also known as south 40 degrees west. And please find the distance of the OVO mobile from Port Life's Good when Aubrey arrives at his 5 p.m. show. Okay? So what I want you to do is this. I want you to pause the video. Okay? I want you to go ahead and highlight some important information here. Step 1. So maybe I'll write these steps out. Step 1, because if you can do this, you'll be successful with all these problems and word problems in general. 1, underline info. 2, make your drawing. You have to. This is something you cannot do in your head. 3, you're going to set up which law? The law of cosines. That's the only way you can do this. Okay? So what you do is take a minute, pause the video, try to solve it. All right? And then when you're ready, unpause, and I'll show you how this one breaks down. All right, here we go. Arbys OVO mobile. Okay, so here's what we need to know about Arbys OVO mobile. We're starting at 10 a.m. We got a bearing 150 degrees. Notice there is no letters on this. So if you don't know what that means, I talked about this in yesterday's lesson, and it was on the homework sheet as well. If you take a look at that sheet that we did from yesterday, it just tells you what happens when you don't have letters, okay? And we're going at a speed of 70 miles an hour. All right. At 1 p.m., we're going to change course. Here's our new bearing, and I need to know what happens at 5 p.m. Okay, so the first thing we know is that if you do not see letters, and as Mr. McCready explained to me, this often happens with navigation, right? This is maybe used in like sailing or like airplanes. A lot of times they actually don't use the letters. They actually just use a degree. And when you don't see letters, you always assume it's north and east. That is, we start from the north and we go clockwise. All right, I think clockwise is kind of what we're naturally inclined to feel comfortable with, though some math actually works counterclockwise. So that'll be confusing at some point. All right. The second bearing is south 40 degrees west. So 150 north looks like this. I start north, and actually, I'm not going to put all the compass pieces there. So here's the thing. I'm standing here. It's like angle of elevation almost. I look north. Here's my north, here's my east, and then I'm going to turn 150 degrees east. So what's going to happen is we're going to blow past, this is 90, right? We're going to blow past this, and we're going to go 60 more degrees. So you could almost see this. This is actually equivalent to the bearing of south 30 degrees east. Okay? Just a fun fact, not really required to know that. Okay? And so I'll label this. So this is our original bearing. All right. The new bearing, again, I'm going to make that dotted. So south 40 west, I look south. Okay, and then I'm going to turn 40 degrees to the west. Right, this is 40 degrees to the west. Okay, so now here's what we're going to do. We now have to solve this. Okay? So to do this, we really got to think about how this breaks down. So we're going to need some kind of triangle. Let me move this down for now. So we start here, we're heading down, and we know that we're only going to be going 70 miles an hour for 3 hours, because 11, 12, 1 p.m., that's 3 hours. Okay, so what that means, and I'm going to have to probably make more space here, is that we've gone 210 miles, right? Because if you drive at 70 miles an hour for 3 hours, you go 210 miles. Now I get here, and I'm going to now brake and go. So remember, when you always make, and I've got to practice what I preach here, you always make your navigationals at each of these points. So here, the navigational changes. Here's my new north. Here's my new south. Here's my new, my new east, my new west, and my new south. And now I've got this 40 degrees right here. That's my new bearing. Okay? And then remember, here is 150 degrees. And then I proceed. This is going to be probably longer because I'm spending a total of, we get to my 4 p.m. show, so it's going to be slightly longer. It's going to be 4 hours. So I go 70 miles an hour for 4 hours. I go 280 miles. Okay, again, I'm just using the speed. And we know this, right? If you get in a car and you're going 80 miles an hour, it's going to take you an hour to drive 80 miles, right? We know that, hopefully. Okay? Especially some of you are going to start driving soon, if you haven't already. So exciting. Oh, I remember those days. All right. Anyway, enough of me trying to live vicariously through you. We need to figure out this red right here. How far from this is Port, life's good, have we gone? So what this is, again, is the law of cosines, and the difficult thing is we need to find this angle right here. We don't know what this angle is, okay? Here's some things that we do know, though. We do know a couple things. Well, we know that if I blow this out, we know that these lines are parallel, and so this is a transversal cutting through parallel lines, right? That is this line, this north-south, is parallel to this north-south, but also this east-west is parallel to this east-west. So it's actually almost like a double transversal, okay? So if you look at this, right, this angle here and this angle here are alternating interior angles, okay? I'm going to show you, I'm going to do it in color because it might be hard for you to see where my pen is. This angle here and this angle here are alternating interior angles, and I'm going to now show you the transversals in green. Let me just get my thicker line back, and let me just switch the color here so you can more clearly see what's going on. My apologies. Okay, here's the first east-west. Here's the second east-west, and I'm just going to move it up. Okay, we can now think about it. Those are my transversals. And again, these are just the east to west part of the compass. And then what I've got is essentially a transversal through that line. And that transversal is just the side of the triangle. So you can see that this and this, these are alternating interior angles. Therefore, they must, by the rules of transversals, be congruent to each other. That's a fact. Okay, so I'm going to delete these lines now. Now, here's the problem. What is this green one? Well, what we know is this is 150 degrees, but since this is 90, this part has to be 60 degrees because that's the additional to get from 90 to 150. And so since they're congruent, this also has to be 60. And a similar thing applies here because notice that this is 40, but these have to add up to 90 because this is a 90-degree angle. making this part of the angle 50 degrees. And so then 60 plus 50 gives me the entire angle at a total of 110 degrees. So remember, as I said in the video the other day, the most difficult part is figuring out the angle. The 210 and the 280, we've got that. It's figuring out the angle. That's the difficult part. Okay? So, here we go. I'm going to call the red distance. We're going to call that, I like to use the letter D for distance. So the distance squared is equal to 210 squared plus 280 squared minus 2 times 210 times 280 times the cosine of 110. Okay, so let's plug that in. I'm going to go to my calculator. My apologies there. It should be up here. So I've got 210. Come on. Oh boy, hopefully my calculator's not giving me a hard time. 210. It's not letting me type with my keyboard, so I'll have to do this manually. 210 squared plus, last time when I used my simulator, it crashed it when it started to lag. But the good news is this is an official TI simulator, so this is less likely to have that nonsense. Ooh. And we get, wow, okay, so we get a total of, so we have a distance squared, and I'm going to put all the decimals there. Again, you can round to 3. I'm not judging you on that. Look, here's the reality. If you can set up a bearings problem, if I don't specify the rounding, like, look, I know sometimes we get a little bit anxious about what does Mr. Murray want me to round to. Like guys, honestly, look, if you can set it up, then rounding is the least of my concern. Believe me, it really is. If I asked you 3 decimal places, I made it 10 points, you set it up and you just miss, you'd be getting easily 9 out of 10 if the only thing, or even 9.5 if the only thing was the rounding. Because believe me, the thing I care about most is setting up the triangle and doing the law of cosines. So I'm gonna do 5, 6, 8, 9. I'm just gonna quickly verify that there were no more decimal places. Okay, and they're not. So now I'm going to square root that because I don't want the distance squared. I want the distance. And now let's round because it's a little bit more reasonable. So the distance is approximately 403.4. And for full credit, it is important that you state your units. I think that is reasonable to ask you to state units, especially when they're clearly given in the problem. So the distance is approximately 403.4 miles. Okay, and so where this comes from is setting up my bearings, putting it together in a diagram, and then using some basic rules of angles, complementary, I found the 50. And similarly, I did a similar thing with angle addition, the fact that it's got to add up to 150, and this is 90, and then alternating interior angles. I do recommend, and on a quiz or test or anything, you're totally fine to do this. If you, like I did before, if you want to come in and actually draw in your transversal, right, like I'm trying to do right now, if you actually want to come in and draw in that transversal, so you can see how the angles are altered, you're 100% welcome to do that. You go wild. You draw all over it. As long as you give me a triangle that makes sense and an answer that makes sense, you do all the drawing you want. All right? All right, so folks, hopefully this do now made sense to you. Thank you for tuning in. I appreciate that. Today we're going to continue on with the bearings problems. We should be having a hangout later today. So please make sure you're ready to ask some good questions there, as we will likely be doing some bearings problems. All right, but just keep up the good work. Keep at it. Have a positive mindset. And remember, let me get my pen for this. You can do it. All right, best of luck today. Don't forget to love math, and I'll see you later.